In the last lecture, we finished our study of Greek mathematics, and in this lecture we move on to Indian mathematics. The origins of Indian mathematics are rather uncertain. The earliest records that we have actually come to us from the Vedas, the great epic poems that were written in the mid to late 2nd millennium BC. The mathematics that's contained in the Vedas is very sketchy, and often what is found there is more of a mnemonic device, and so it's open to a great deal of interpretation what exactly is being described in the Vedas. But there is a collection of works that really are appendices to the Vedas, what are known as the Sulba Sutras, written in the period roughly 800 BC to 200 BC. And these describe how rituals were to be performed, and they lay out the way in which altars were to be constructed, things such as this. And so there's a fair amount of mathematics that's contained in the Sulba Sutras. And so one of the problems that the Indian priests would face is one of, say, doubling the area of an altar. And in order to double the area, what you need to do is take the length and the width and multiply each of those by the square root of 2. So the Sulba Sutras explain how to find a good approximation to the square root of 2. They also explain how to compute volumes. If you want to double the volume of a given altar, you need to multiply each of the 3 dimensions by the cube root of 2. And so these also explain how to find good approximations to the cube root of 2. We do find references to the Pythagorean theorem here. We also find references to interesting counting problems, because one of the ways in which the Vedas and the Sulba Sutras and these other poetic forms was memorized was to recombine the syllables. And people were often interested in the number of ways that these could be recombined. And some of our earliest work on what we call combinatorics actually comes from these kinds of investigations. The earliest recorded writing that we have of Indian mathematics also makes it clear that they were using a very different system for recording numbers, a system that's much closer to the system that we use today. They had 9 symbols for the digits 1 through 9, and then they would combine these with special symbols for the powers of 10. So you had a symbol for 10, a symbol for 100, a symbol for 1,000, and so on, and you put these together. So if you wanted to represent a number like 327, you'd write the digit 3, the 100 symbol, the digit 2, the 10 symbol, and then the digit 7. It was not yet a full place value system in our modern sense, and one of the problems was that at this point, the Indian mathematicians did not have the digit 0. They did not have this placeholder, which enables us to tell the difference between 307 and 37, and so they used symbols for the power of 10 that was being recorded. This system, as we'll see in the next lecture, was also used by Chinese mathematicians. And one of the interesting questions out there is whether this system was originally created in India and then imported into China, or originally created in China and then imported into India, or perhaps created someplace else, such as Central Asia, and then imported into both of those countries, or maybe it just happened to come up independently. It was an idea that made good sense in both India and China. But at roughly the same time, we see a very similar system of writing the numbers. 0 itself would be invented sometime, well, nobody's really sure, sometime between 300 and about 600-700 AD. The earliest actual recording that we have of 0 being used as a placeholder in a number is actually in a Hindu temple in Cambodia that was constructed in the year 683 AD, and the year as recorded in the Hindu system was a number that actually used the digit 0. 0 had been used a bit earlier, not as a placeholder, but as a number that could be manipulated by the 7th century astronomer Brahmagupta. And this really is the first time that we have record of somebody working with a symbol that represents nothing, a symbol for zero. Zero now enters the numerical system. And Brahmagupta did explain what happens when you add a zero to a number or subtract zero from a number, or what happens if you multiply a number by zero, you still get zero. And he wrestled a bit with this whole issue of what happens when you divide a number by zero, and essentially sort of left that up in the air, what happens when you try to divide by zero. In today's lecture, I'm going to focus on 3 great Indian astronomers. Again, these were men who were best known for their contributions to astronomy, but they also did a great deal of work in mathematics generally, in algebra, in number theory, and other areas of mathematics. These are Aryabhata, born about 476, died sometime in the middle of the 6th century A.D., Brahmagupta, that I have already mentioned, who lived in the 6th century, and then Bhaskara Acharya. Acharya is an honorific title. It means scholar, so this is really Bhaskara the scholar, who lived in the middle of the 12th century. As I said in the last lecture, the astronomical works that were developed in Alexandria and elsewhere in the eastern Mediterranean would be taken up by the Indian astronomers, and this appears to have happened in the first several centuries A.D., under the Kushan Empire. Now, the Kushan Empire was an empire that had come down out of Central Asia to take over northern India, and it had strong connections with an older Hellenistic empire, the Seleucids, who were based in Persia and also in Central Asia. And largely because of this, the Kushan Empire maintained strong connections with the eastern Mediterranean. And we do know that they brought astronomical texts from Alexandria and elsewhere. Strangely, it seems that they never actually imported Ptolemy's Almagest. That appears to be one of the books that was not translated into Sanskrit. But many of the other astronomical works of that same period were brought into India and were translated into the Sanskrit. And fairly soon after receiving the Greek texts, the Indian astronomers began to build on those and further develop their idea of trigonometry. The first of the great Indian